This is an RFV 252 78-1 gearbox. Before that is a 1hp-4pole clutch brake prototype. This is our 1 horse 80 frame marine motor. It can be made up to 2 horsepower in this size. We have our motor mounted VFD. And on the VFD, these are our 3-phase going out. Coming in is single phase, 115 volt. This is our neutral. This is our line. Green is ground. Up here, these are these 2 wires go to a limit switch that's set for the home position. These other wires, they go to the back of the motor where we have a sensor bearing. It's mounted internally. You can see it's completely sealed, the IP66 motor. With this cover, we have a cover that goes over top of this. I just had this removed so you can see it. You can have IP56 protection. We also have a Form C programmable relay right in here. It's, the connections are these 3 there at the end, which is normally closed, common, and normally open. What else we have connected to the VFD is the programmer, which has a plus and minus 5 volt DC, and then the TX and RX, which is the send and received commands from the programmer. The other things I have connected here, right in here, this is our, goes to our call station. So we have common, first call, second call, and third call. And so our wiring to operate the lift needs 1, 2, and 3. Coming out, this is our 115 volt single phase power feed, which we could have a GFI Stinger, but this is for testing, so it's not needed. Here's our winder. Our winder is 2 1/4 inch. Off of that, it's threaded to guide the cables as they wind. It helps for cable life. Below us, we have the head with the hook. And below that is an 1,800-pound 75 horse 6-pole motor. That's the heaviest thing I had in the shop to lift. The winch itself, so we have 1 horse, which is delivering 36 inch-pounds, going through the clutch brake, times 78 at 96% efficiency. That's our raw output torque. In this case, the gearbox is the inboard bearing, and the outboard bearing is a brass bushing. This is less efficient, we have more friction than what we should have. A better design would be to have a ball bearing on each side, like a flange block or a pillow block, and I'm looking at developing something in that, using a stainless steel insert with an aluminum housing, and that would allow for misalignment. So this is very sensitive to alignment, so I've noticed some drag, a little parasitic drag. Okay, up on a ladder. So this is our standard North American 3-prong UL plug, 115 volts. Here's our motor. Next we have is our call station. Our call station has membrane switch keypad on it. So first position, second, third, stop for a light, and then there's a program additional remote button. Inside of this call station, I just made this with our laser. Inside of that I have a 4-channel RF remote, and it made the wiring really simple. and it's easy to get access to the remote this way instead of putting it in the VFD. Just put it inside, and with this 4-channel remote, you can have call the first, second, third floor and stop. And I'm looking to make a 5-channel remote where I can also add the light to it. Above that is our programmer for the drive. You can control the drive manually. You use this for setting up, to set up the stop positions. So with this system, we have the home position, which is 0. We have the second position, which you can set between home position, first position, and then the ground is the third position, or the second. I keep saying that. The ground is the second position. So we have 0, whatever number you want to count in rotations, and the next position after that you would count in rotations and program it in. So what's happening is the sensor bearings feeding back to that control board that I shown you, the counts of the rotations of the motor. So the accuracy of the output of the winder is going to be whatever the ratio is. So in this case, it's 1/78 of a rotation of the output winder. We can stop accurately to that. Now, say like a boat lift winch, we might have a 280, 300 to 1 ratio. So we would be able to control the output rotation to whatever, 300, almost a degree of rotation. If you're, let's say 360, you'd have a degree of rotation of the output winder. So very accurate. The way the move works, so we have our start position, acceleration to run speed, and then based on the first position stop that you program, it's going to anticipate, decelerate, and then it's going to decelerate again at the stop deceleration. So from, let's say it's going to go for 60 hertz here, it's going to slow down to 20 hertz, and it's going to go to 0. And that's what we're programming in here. These are the user parameters. So right now the travel between position speed is set at 60 hertz. The position approach speed is 20, which would be, so it'd be 60 hertz, 20 hertz, and then the stop is 5. So it allows us to creep into the stop positions very accurately, and it gives the motion a very gentle motion while having a very fast speed in between stops. So likewise with the acceleration, or I'm sorry, if we were from position 2 accelerating back to 1, it's the same. And going position 2, when you stop, it'll decelerate it like this, and it'll decelerate to position 0 like this. So it's all programmable within the system. And that's all done from the keypad here. You can read the position that we're at now, go into the monitor mode, parameter 27. Right now we're at the 88, which is our second position. So if we're going to go to the third floor, or which is the 0 position, okay. Now let's go to the first floor, which is second position. I want you to appreciate the approach, deceleration, and stop. Now, I purposely set that to be very close to the ground, and you can see how tight we are, yet we're not touching. Just to kind of demonstrate the accuracy, you can still move the motor. So in setting up a boat lift, a gate, an overhead door, a cargo lift, a residential elevator with a system like this, there is no limit switches other than the top home position switch. In this case, I'm using a whisker switch. It's normally open and closes when the cable connects with it, which I can demonstrate, and that sets the 0 position. A magnetic reed switch on something it might be more accurate than this because the cable position can change depending on how it lines. But so far in testing, this has proven accurate. So we're going to go to the 3rd position and we watch it meet that whisker switch. So that's our rotations counting down right there. Right now we're moving at 12 feet per minute, which is pretty quick for 1,840 pounds with a 1-horse motor. And that's because of the efficiency that we have. With helical gearing, we have 96% efficiency. All right, we've reached 0, so the home position's clicked. So let's go to the 2nd position. Should be 88. And ground again. Again, stopping just before the ground. Here's our remote key fob. A is stop, B is 1st position, C is 2nd floor, D is 3rd floor. So if we want to go to the 2nd floor, if it was, say, an elevator, or if we wanted to do this, if it was, let's say, a walk-in door, like this one here, we wanted to have a full open position, that would be the home position. Walk-in height could be our 1st position, which is would be C, and then fully closed would be D. So we could, fully closed would be B, with fully open would be D, and stop would be A. So lots of different applications for this basic system. We can make it in different motors, different horsepowers.